In Chapter 11, we're going to be learning all about what's called rational expressions. And if you look at that word rational, you'll notice that the root word is ratio. And a ratio is nothing more than a number compared to another number written as a division. So a rational expression is nothing more than an expression in the form of a polynomial over a polynomial. For example, 1 over 3, that's a rational expression. You could think of it as 2x over x plus 2. That's a rational expression because it's written as a ratio. So the main thing you need to remember in this entire chapter and all the examples is think fractions. Everything we're going to do is going to be about fractions. Here are some more examples of rational expressions. You could have 3 over x plus 2, or you could get a trinomial over a binomial like x squared plus 4x minus 1 over x squared minus 4. Now there is something that we have to be aware of called an excluded value. Because if you remember back earlier in the semester, we talked about the one thing you can never divide by. You can never divide by 0. And since we're going to be putting in numbers for x, there are certain numbers that we can't put in. So the excluded value means numbers that are not allowed to be put in for x. So as we look at example number 1 here, 3 over x, it's pretty obvious that if I put in 0, we're going to say, well, 3 over 0 would be undefined, and I can't do that. So we put a little note off to the side and we say, oh, by the way, for this rational expression, x cannot be 0. But any other number I want to put in there, that would be fine. So this statement right here, x cannot equal 0, I am excluding it. I'm leaving it out. This is a private club, 0, you're out. So that's what we call the excluded value. On example number 2, I need to think, well, what number would turn the denominator into 0? Because I could actually say 3 over 0 plus 2. If I put 0 in there this time, 0 plus 2 is 2, and that ends up being 3 over 2. Well, 3 over 2 is fine. The problem is if I'm going to end up having something divided by 0. So I'm looking at this, I'm saying, if I put in negative 2 for x, negative 2 plus 2 would turn that into 3 over 0, and that's what can't happen. So my excluded value for example number 2, I would simply say, you know what? X is not allowed or cannot equal negative 2. And this would be my excluded value. On those examples, it's a little bit easier to see. When you get something like example number 3, x squared plus 4x minus 1 and x squared minus 4, I have to think a little bit. If you're very good at factoring, which you will be by the end of this chapter because you're going to need that skill a lot, you'd look at that denominator and think, well, what multiplies to make x squared minus 4? And this is the difference of squares, x minus 2 times x plus 2. That's the only way to get two terms with a minus in the middle, remember. Well, now I can look at that and think, well, what's going to turn each of those groups into 0? If I put a 2 in for x, 2 minus 2 would turn into 0, and I can't divide by 0 on the bottom. So x cannot equal 2 in this rational expression. That's an excluded value. X plus 2 is the other factor. If I put in negative 2 for that x, that would turn that group to 0, times the other group would still be 0. So in the denominator, I would end up with 0. So I have to say, you know what? X also cannot equal negative 2. So any value that you would plug in for x has to go in for all of the x's. But if that value you plug in turns the denominator to 0, that number is not allowed because the one thing we cannot do, we can never divide by 0. So we have to be aware of what values are not acceptable. So keep that in mind as we go through some of these examples. So how do I simplify things like rational expressions? Well, let's start with something very basic. If you know how to simplify 2 over 6 as a simplified fraction, then you know how to simplify this first rational expression. You may not think about it anymore, but what you're doing is you're saying, well, 2 is the same thing as 1 times 2, and 6 is the same thing as 1 times 2 times 3. If we wrote that out in all its factors, we can see that the numerator and the denominator share a common factor of 2. Well, that's like having an extra factor of 1. So if I wrote that as 1 times 1 over 1 times 1 times 3, we don't need all the extra 1's. So we say, all right, we've got 1 and 1 and 1 and 1. Really what we have is 1 over 3, because I at least need to keep one of those 1's in the numerator so I still have a rational expression. I'm sure I didn't blow your mind with simplifying 2/6 to 1/3. We're going to use the same idea to simplify this rational expression. 10 is the same thing as 2 times 5, and m to the third is m times m times m. On the bottom, I've got 1 times 2 times m times m. To simplify this, we're going to eliminate common factors, because a factor in the numerator and denominator essentially boils down to a factor of 1. So m and m would reduce to a factor of 1. This m and this m would reduce to a factor of 1. I see a factor of 2 and another factor of 2 that would reduce to 1. So all I'm left with on the top is this 5 and 1m, and all I'm left with on the bottom is 1. So this would be the same thing as 5m over 1. And if you get a 1 in the denominator, we don't need it there. So this would be 5m. And that's how we're going to simplify rational expressions. Think fractions. Example number 2. Another thing you have to understand is x minus 2 on the numerator is an entire group. So you might be tempted to go, oh, I'll cross out the 2 and the 6. That reduces it to 3. That would be fine, except groups cannot be broken up. X minus 2 is a group, so we can't do it that way. We have to think of x minus 2 as one number. And 3x minus 6 is one quantity, one group of factors. So we're going to treat this like we did factors when we were solving quadratic equations. I can factor quantities. X minus 2, there is no common factor and there's not 3 terms. But in the denominator, 3x minus 6 has a common factor of 3. We'll go into both 3 and 6. So when I rewrite this, I say, you know what? The denominator would be the same thing as 3 times x minus 2. And the numerator is still just x minus 2. Well, we're talking about factors. If the factors are the same, they can be eliminated because it reduces to 1. So now that I have 2 factors of x minus 2, this x minus 2 can eliminate with the denominator factor of x minus 2, leaving me just 3 in the denominator. So you might be tempted to just write 3. But the denominator reduced to 3. So we need to still have the fraction bar that shows 3 is in the denominator, and you can't have a rational expression or a fraction with no numerator. So we think, oh yeah, really it was like 1 times the factors of x minus 2, so it reduces all the way down to 1 over 3. So the main thing you got to remember here is groups are factors. X minus 2 is one factor, not 2 separate things. So we can use that in this example number 3. I like to write out my factors. 16 is the same thing as 2 times 2 times 2 times 2, and then times x for the x squared. For the denominator, all I can see is that there's a common factor of 4 because this is one group. So I have to factor the group. I can factor out the common denominator, or the common factor rather, of 4, leaving me x plus 2. Well, 4 is the same thing as 2 times 2, so let me rewrite it that way. And some of you may already be noticing and going, well, I know 16 can divide by 4. I don't need to write it out as all these 2's. That's totally fine. I'm just doing it so you can see it very clearly. So this factor of 2 and this factor of 2 would reduce to 1. So would this factor of 2 and this factor of 2. So what I'm left with is the 2 2's and the 2 x's being multiplied together, which would equal 4x squared. And in the denominator, I'm actually left with this group, this quantity of x plus 2. So my simplified expression would be 4x squared over x plus 2. And that is the final simplified expression. Again, you're going to be tempted to say, well, there's an x up here and an x down here. Yes, there is. But we cannot eliminate them because this x in the denominator is being grouped with a 2 using this plus sign. So if you see a plus or a minus, you cannot eliminate because that's a group. If you look up above, in the numerator it was 2 times 2 times 2 times 2 times x times x. No pluses, no subtractions. In the bottom it was 2 times 2 times x plus 2. So when I got to that plus, I left the x plus 2 as one factor. And that's how you have to think of it. Example number 4, the factoring gets harder, but the idea stays the same. In the numerator, I noticed that I have a common factor of 5. So 5 times x would give me 5x, and 5 times a negative 5 would give me minus 25. In the denominator, I've got to think what multiplies to 25 but adds up to a negative 10, and I realized that would be an x minus 5 and an x minus 5. Here again, I'm seeing common factors. It's an entire group, but they're common. This factor of x minus 5 in the top can simplify and reduce with this common factor of x minus 5 in the bottom, leaving me just a 5 in the numerator and one group of x minus 5 in the denominator instead of 2. So this would equal 5 over x minus 5. And you'll notice that if I only have one factor as a group left over, I don't put the parentheses. You could write it like this. That wouldn't bother me. But typically we don't. We just leave it as x minus 5 because we know that's a group because there's a subtraction. And that would be the simplified form of this expression. So let's do one more. What if you end up factoring and nothing cancels out? You've got 2 minus x, so there's a subtraction, so that's one group. In the denominator, the 3x minus 6, again, I noticed that this is a common factor of 3. So I have 2 minus x that didn't factor in the top, but I'm pulling out a 3, leaving me an x minus 2. Well, everything looks pretty good. It could have been a 2 and the 2. It's x minus 2 and 2 minus x. Well, those are exactly opposite. So what we need to recognize is, when can I factor out a negative number? So if I'm looking at 2 minus x, anything has a common factor of negative 1. So if I pull out that common factor of negative 1, it actually turns that into negative 2 plus x, because a negative 1 times a negative 2 would have gotten me the positive 2, and a negative 1 times positive x would have gotten me a negative x. So if I can pull out a negative number and then think of it as negative 2 plus x, but I'm actually going to think of that as a negative 1 times a positive x minus 2. If everything is exactly the same except the signs, you can pull out a negative 1 and then look what happens. My common factors of x minus 2 end up being the same, and this reduces all the way down to negative 1/3.